No. Okay, welcome back. Let's get started with this gymnastics to get the screen and use it. Whoosh. Luckily, in an exam situation, you will not have to do this. Try to imagine if I gave you full pieces of paper and the first thing you need to do is to erase whatever I have put on it. Okay, so let's move on to linear algebra. Da-da-da. This is what a lot of people have been waiting for. Not really. So here's a system of linear equations. X plus Z equals 0. 2x plus y plus AZ equals 0. Y plus Z equals B. And the question is, find all values of A and B for which this system has no solution, one solution, infinitely many solutions. You've done zillions of exercises of this type. So these are relatively easy 8 points for you. How do I start solving such an exercise? For instance, I could put up the augmented matrix. Why not? Let's do it. 1, 0, 1, because 1 multiplies x, 0 multiplies y, 1 multiplies z, 0, 2, 1, a, 0, 0, 1, 1, b. Okay? Do we all agree this is the augmented matrix? I might have made a mistake. Now, you know, let's not start swapping rows straight away, shall we? We already have a 1 in the right place in the first equation. So let's use it. I already gave you a 0 under it in the third equation. So what is it that I want to do? Okay, I want to take 2 times minus 2 times row 1, and I want to sum it to row 2. And let's see what we get. Row 1 does not change. Row 3 does not change. Row 2 does change. So what does the 2 become? It becomes 0. Okay? What happens to the 1? Nothing, because it's 1 minus 2 times 0, which is 1 minus 0, it's 1. Okay, so what happens to the a? A minus 2. Excellent. Okay, and here we get a 0 because it's 0 minus 0. Hey, we are getting there. So what is it that you think I would want to do now? Okay, I already have a 1 here. That's good. That's what it should be. What I want to get something below that 1. I want to get a 0. So how do I get a 0 there? Well, we just subtract the second row to the third. Minus row 2 plus row 3. Okay, so what is it that we get? The first row does not change. The second row does not change. Okay, what happens to the third row? I get 0, 0, and then I have 1 minus a plus 2. So I get 1 minus a plus 2 is 3 minus a. Okay, what happens to the b? Just stays a b. Okay, now I think we are in business, aren't we? Note, if I remember correctly, someone did, I don't know, 15 elementary row operations and made a mistake. Never do that. This is not, I mean, it's unlikely that it's necessary. It's very unlikely. So keep it simple. Remember the KISS method. Kiss yourself during the exam. That you can do. You're probably not allowed to kiss someone else because otherwise it looks like you're looking at the exam of that someone else. But yourself you can kiss. Okay, so what can we conclude now? When is it that this thing can have, okay, sort of, remember, one solution. When is it that this thing has one solution? Okay, so when a is not 3, here we get a number, here we get a number which is not 0. Which means that no matter what b is, we can get a 1 there because we can divide by 3 minus a. In that case, you got a 1 there, and that whatever you get for b divided by 3 minus a is the only value of z. But then z has only one value, so y has only one value, and so on. The matrix is going to have rank 3, so there were 3 variables. This means each variable is going to get exactly one value. Okay, so what if actually a is equal to 3? If a is equal to 3, the last row becomes 0, 0, 0, b. So what are the possibilities here? Okay, so if b is 0, you got infinitely many solutions. Let me write sols for solution because I don't have space. Okay, why do you have infinitely many solutions? Because z is a free variable. In this case, the rank is 2. The leading variables are x and y. Z can be arbitrary. What if b is not 0? No solution whatsoever, inconsistency, because you have 0 equals to something which is not 0. Yuck. Where this happy face means no solutions whatsoever. Ladies and gentlemen, 8 points. And you choose from the Dutch jury. Groetjes, greetings from our Dutch friends. I apologize to the Dutch, anybody Dutch in the room. My Dutch is not particularly good. In fact, it's limited to this word and I cannot even, well, not quite, but I cannot even pronounce it correctly. It's smakelijk. Okay? So far, so good. We've done a lot of exercises like this. So you should rejoice if you are to solve an exercise of this type. Very little calculation. Only understanding. You will not find in the exam solve a 10 by 10 system of equations. You don't get it. Okay? Shall I kill this? Ah! Okay. Okay, it doesn't want to become bigger. Thou shalt become bigger. What have I done? Okay, yeah. Excellent. The next exercise has got to do with linear transformations. One of your best friends, aren't they? Okay, so we are given a linear transformation f, and I tell you that f of 1, 2 is equal to 3, 7, and f of 3, 0 is equal to 9, 9. Question. Find the matrix that induces f. Now, I have the feeling I already solved this on Piazza, but it was probably a private question. So let's do it publicly for everyone. Okay, let me ask you. Well, first of all, what is it that I need to find in order to get the matrix? Neo. I need to find f of 1, 0 and f of 0, 1. In fact, you already know just by looking at it what f of 1, 0 is. It's 3, 3. Why? Because f of 3, 0 is 9, 9. 3, 0 is 3 times 1, 0. Oops. That's because f of 3, 0 is actually 3 times f of 1, 0. Because f is linear. So that took 5 seconds to do. You just use the fact that this is equal to f of 3 times 1, 0. And then since f is linear, that's equal to that. So 9, 9 is 3 times f of 1, 0. So f of 1, 0 is 3, 3. So if you know what a linear transformation is, and what are the properties that define linear transformations, this is piece of cake. This is celebration. Your glycemic index goes up just by looking at this, because it's a piece of cake. If you don't know, then, well, your glycemic index stays the same, but that's not a good thing in this case. Okay? So our next job is to figure out what f of 0, 1 is. That's only slightly more work. But since you know what a linear transformation is, it's just a matter of working on it. And now I'm afraid I need to make a little bit of space. So I will remove this part here. Now, how do I find f of 0, 1? I know what f of 1, 0 is, and I know that f of 1, 2 is 3, 7. Okay. So f of 1 That's because 1, 2 is 1, 0 plus 0, 2. That's what I was suggested by one of your colleagues in the front row. But now f is linear. So what is this thing equal to? F of 1, 0 plus f of 0, 2. Well, I know what f of 1, 0 is. I just calculated it. So this thing is actually equal to 3, 3 plus f of 0, 2. Okay, so what is f of 0, 2? Well, you know, this is really an equation that tells me that this thing here is equal to that. So f of 0, 2 I obtain by subtracting 3, 3 from 3, 7. Is equal to 3, 7 minus 3, 3. So that's equal to 0, 4. And I'm running, oh yeah, thank you. This is called AI. Okay, so f of 0, 2 is 0, 4. Yeah, but then what is f of 0, 1? I can remove the question mark, elementary dear Watson, because f of 0, 1 is, if f of 0, 2 is 0, 4, it's 0, 2. I just need to divide by 2, 0, 4. So, Madame et Monsieur, ladies and gentlemen, guys and gals, the matrix, and here Neo it will be revealed, is what? The first column is 3, 3. The second column is 0, 2. That's the matrix that induces F. And if you're in doubt, it just takes less than a minute to multiply this matrix by 1, 2 and figure out that you get 3, 7, and by 3, 0 and figure out that you get 9, 9. That's just to check that what we've done is correct. Eight points from the Belgian jury. I don't speak Flemish, sorry. Shall we? I don't think we've been to Denmark yet. Perhaps we have. Yeah. The Icelandic jury always, so the Icelandic song always gets points from Denmark. Okay. Any questions about this? You know, the bottom line is, remember the properties of a linear transformation. If you know those, that's a piece of cake. If you don't, write them down on your A4 sheet of paper. Next question. Find the inverse of the linear transformation G that is induced by the matrix 1, 4, 1, 2. Okay, so G is induced by this matrix. I want to find the inverse of this linear transformation. Now, who induces the inverse of G? If G is induced by this matrix, its inverse is induced by what matrix? the inverse of this one. So all we need to do is to do a very complicated computation of the inverse of this matrix. Let's do it. As you can see, this is going to be really calculation intensive. Yeah, there is also a shortcut. So you can use in this specific case the determinant. That's the only determinant that we've introduced in the course. So you can write it down on your A4 sheet of paper and solve this exercise. Now, shall we do something more interesting than this? I mean, you can do this. I know you can. Let's do something more conceptual. Okay? Bing. But let me tell you one thing. Once you've calculated the matrix, which is the inverse, to find the inverse of G, what you need to do is simply to multiply that by xy, and you get the expression for the inverse of G. That gives you G minus 1 of xy. That's the conceptual part. Okay? Let's do something perhaps slightly more interesting. The next two questions, by the way, those were 7 points from the Norwegian jury. Okay, the next two questions have to do with lines. I think you can solve those. Do you want to? So one was the following. Give the equation of the line that goes through the points P, 1, 0, 1 and Q, 0, 1, 2. So what's the equation of the line that goes through these points? Of course, this. But that's not an equation. So how do we find the equation for the line? What is it that we need? You know, I'm sort of directionless in my life. I need someone to give me directions. So, give me a direction, please. The direction vector for this line. What would be a natural choice? Okay, yeah, it's the vector that goes from P to Q, which is Q minus P, so it's 0, 1, 2, minus 1, 0, 1. And again, I think you can appreciate how I keep the computations very complicated. So that's minus 1, 1, 1. That's the direction vector. So what's the line? Well, it has to go through one of these points. So let's pick P. One, 0, 1 plus T times minus 1. So that would be minus T because I picked this. I multiplied by T. That's the X component. Plus T plus T. Of course, you can do more complicated calculations if you want, but why should you? Yeah? That's the line. And that will give you 3 points from the Swedish jury. Bra. Okay, the next question has to do with orthogonal vectors. When are two vectors orthogonal? When their dot product is 0. That's all you need to get another 3 points. So let's do something slightly more interesting. The next question is worth as many as 6 points. From the Aalborg University jury. OB. Okay. Let's do it. Find the shortest distance from the point P101 to the line that goes through the point P0, which is conveniently the origin, and has direction vector D, which is 1, 1, 1, just to keep the calculations as heavy as possible. Okay, we've done trillions of exercises of this type. What's the picture? That's P0. That's the line with direction vector D. That's my P. That's my U. That's my U2, rock away, rock away. And this is the projection of U on the vector D. So that's the projection. That's my U2. And the distance of P from the line is the length of U2. The distance is the length of U2. The rest is merely calculation using what? Using the equation for the projection that, of course, you will write down on your A4 sheet of paper. It says that the projection, which we have very often called U1, the projection of the vector U on D is nothing but what? The dot product of U with D divided by the square of the length of D times the vector D. And then U2 is nothing but U minus U1, where U is, of course, the vector that goes from P0 to P, and that's just P. In terms of coordinates, it's 1, 0, 1 because I've chosen P0 so that it's 0, 0, 0, just to make your calculations as heavy as possible. You know, subtraction can be tricky at times under time pressure. Any doubt about this? Anything mysterious? If not, let's do some probability. The P word. Okay, let me save some time by not erasing this wonderful curve that I've just done. Okay? The first question has to do with independent events. The only thing you need to solve this exercise is to know when two events are independent. So when E and F are independent, when is it that they are independent? The probability of E intersection F, which is the probability that both event occurs, should be equal to the probability that E occurs times the probability that F occurs. E and F are independent if and only if that's the case. So let's take one example from this exercise. A means, okay, so we have our die. There you have it. Whatever. We cast it twice. The event E is even number on first toss. Event B is odd number on second toss. Are they independent? I would say so. Intuitively, the fact that I get a 2 on the first toss should not influence whether I get a 3 or a 5 or a 1 on the second toss. So let's use the formula. What is the probability that I get an even number on the first toss and an odd number on the second? Well, how many possibilities are there overall? 36. 6 for the first toss, 6 for the second. So 36 possible combinations. Now, an event, so an outcome is in A intersection B if and only if the first time I got an even number. The second time, I got an odd number. Well, how many such possibilities are there? There are 3 even numbers and 3 odd numbers. So overall, all the possible combinations are 9. So each one of the even numbers can be paired with 3 odd numbers. There are 3 such, so 3 times 3, 9. 1/4. Yeah, but what is the probability that if I toss a die, I get an even number? It's a half. There are 3 out of 6. Well, it's the same probability of getting an odd number. Hey, a half times a half is a quarter. So yes, the two are independent. So you answer with a smiley. If they were not independent, you would answer with an anti-smiley. Okay? So there was another question like this, but the pattern, you see it. Let's do the next exercise. You throw a fair die 5 times. 5 throws. What is the probability that at most one of the throws gives an odd number? So at most one means 0 or 1. Now, does this smell like a trial? A B trial, where B stands for Bernoulli. This is a Bernoulli trial where we are interested in whether when we cast a die, we get an odd number or not. So success means odd. Failure means even. What is the probability of success? Well, we calculated it before. S for success is a half. The probability of failure is also a half. Okay, so what is the probability of getting 0 successes? It's, you get failure 5 times. And there is only one way of getting that. It's all failure, 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 failure. What is the probability of getting exactly 1 success? Well, it's again these times the number of ways of getting exactly 1 success. How many ways are there of getting exactly 1 success? You don't even need to calculate the binomial coefficient. You get 1 success either in the first, or in the second, or in the third, or in the fourth, or in the fifth. It's Sensuous K, but in this case, it's just 5. Because your only success, you get it in one of the throws. So you either get it the first one, the second time, the third time, fourth, or the fifth. But in general, it's N choose K. In this case, it would be 5 choose 1, which is 5. Okay? So you just need to sum these two, and you get the result. The probability of getting at most 1 odd number is the probability of getting none of them plus the probability of getting 1. Because it's either 0 or 1. 4 points from the Russian jury. And now we get to the Icelandic jury. So now we are playing at home, or you're playing at home. I'm playing at one of the advantages I have is that I have many homes. So I'm always at home. Well, sort of. Okay, 10 points. In front of you, there are 2 identical looking coins. One of them is biased and comes up tails 75% of the time. So 3/4. The other is counterfeit and always comes up tails. So tails with probability 1. You pick one of the coins at random and you flip it 3 times and you get tail, tail, tail. What is the probability that you got the counterfeit coin? What does this smell of? I want to calculate. So F is I picked the counterfeit coin. The one that always comes up tails. E is I got TTT. I want to calculate the probability of having picked the counterfeit coin given that I get tail, tail, tail. Who are we going to call to solve this exercise? Bayes' theorem. We call Reverend Bayes. Spiritic session. Bayes from the textbook tells us that this is nothing but the probability of F times the probability of getting E given F divided by the probability of getting E, which you know how to expand and calculate. We've done zillions of exercises of this type. So basically, by looking at this exam, the rest is calculation, and it's not complicated calculation. So looking at this exam, I think you get the feeling that you can celebrate remember the exam is, as I promised on the first day of the course, a celebration of your own learning, of your own knowledge. So if you learned something, as you have, through the course, this is piece of cake. You choose your cake. Piece of chocolate if you don't like cake. Piece of something you like. I'll cut if that's what you like. But don't bring it in an exam because it's not allowed. Okay, there was one more question, but anyway, I don't have time for that. Okay, so the question is, what is the probability of you getting a high grade if you study hard? The probability is nearly 1. I say nearly 1 instead of exactly 1 because, you know, I mean, shit happens. So if you study hard, perhaps you get only 8.5, which is still a high grade, instead of the 10 that you would have got if the wind was blowing from the west. What can I say? Okay, Rapni is out there waiting for me to finally call this a day. I just want to spend a few words thanking all the people who've been here consistently, not because I don't love all of you, it's just because I find it easier to love the people whom I know. And these people were just making it worth my while to be here for 24 course sessions, listening to my sick jokes, and most importantly, contributing to every lecture by answering every question. So I learned from them more than they learned from me. Thank you.